Michael Hecht. I'm the Associate Director for Research Management at MIT's Haystack Observatory. I'm also the Principal Investigator for the MOXIE technology demonstration, ISRU technology demonstration on the Mars 2020 NASA rover. ISRU, I always tell people, stands for Living Off the Land, but LOL was already used, so we call it ISRU. In situ resource utilization, meaning using resources that are in situ, that are in the place where they are found, and using them in the broader sense to limit and minimize the amount of stuff we need to take with us when we go somewhere else, when we go to Mars, when we go to the moon, when we go to space. Well, in a broader context, space resources are going to be lots of things that we already use. You know, one of the sort of most amusing ones is vacuum. Vacuum is actually a space resource, and it's used in the space station. It was used before that in the shuttle for manufacturing, because vacuum is hard to achieve on Earth. So it really can be anything. It can be the atmosphere of Mars that's used for a parachute. When we talk about ISRU, we're usually talking about really resource transformation more than utilization, turning one thing into something else, turning, in our case, carbon dioxide on Mars into oxygen to be used for a propellant system. So those really are the resources, the chemical resources, the material resources, the rocks, the soil, the ground, things you can make into bricks, anything you can transform into a useful form. What got me interested in ISRU? In a sense, it goes way back to the 90s when I was involved with the Mars 2001 mission that never happened. It never happened because after losing Polar Lander, NASA just put a halt to that whole series. But at the time, we were working for the human exploration folks who were interested in starting, even in the 90s, to look at what it would take to get astronauts safely to Mars and home again. And they were interested in things like radiation. They were interested in hazards associated with the materials in the environment, mostly the ground, the regolith, the soil. And that's where I got involved. But they were also interested in ISRU, and they funded a payload called the Mars In Situ Propellant Production Precursor, which was called MIP. And that was run out of Johnson Space Center. But those are all our, if you will, our shipmates. Those are our crewmates on the Mars 2001 lander. So I've been interested in it since then. And the opportunity so many years later came along to pursue it seriously, to send the technology to Mars and to try it out and see if it works. I couldn't resist, getting involved with it again. For anyone who has read or seen The Martian, Andy Weir's book or the movie with Matt Damon, the MOXIE is the oxygenator. It's the Mars Oxygen ISRU experiment, and its purpose is to take the carbon dioxide in Mars and turn it into massive quantities of oxygen. We're looking on a full-scale version of MOXIE of making about 30 metric tons of oxygen. This is a 1 to 200 scale prototype to see that it works. But the idea is not because an astronaut crew is going to breathe 30 tons of oxygen. It's because that's how much the fuel is going to consume in lifting that astronaut crew off of Mars and getting them back to an Earth return vehicle. If you had to take that 30 tons of oxygen with you to Mars, not only would it be horrendously expensive and complex from the point of view of coordinating all the different launches, it would probably put a human Mars mission off by 15 or 20 years, I would bet, before the resources could be collected to do that. So we can really short-circuit the process by making that huge, massive item disappear from the launch manifest. Why use space resources? Well, I think there's a short-term reason and there's a long-term reason. The short-term reason is that the same reason every expedition of exploration on Earth has used things they found along the way. It's just too much to bring otherwise. That's really short term. In the longer term, let's take Mars, for example, although the moon equally true. If you want to establish a self-sustaining presence, and I'm not talking about cities, I'm talking about McMurdo Station, research stations, it's not wise to rely on having everything you need be brought from Earth. So you'd like to make as much on-site with available resources as you possibly can. You know, it's a funny thing, the IBM just announced the successor to Watson, something called the Debater. And they tried it out against professional debaters, and they would pick a topic and the debater would defend it. And the topic they just chose was why government should support space exploration, should subsidize space exploration, and the debater won. So maybe you should be asking the computer that question. You know, these days that question is usually asked in the context of why not just let private industry do it? And yes, Elon Musk wants to go to Mars. Maybe he will, and I'm sure if he does, everyone at NASA and associated with NASA will applaud. We're not going to sit around and wait for that either. If we hope to explore and expand, you know, human presence in the solar system, we need to do it ourselves, and it's too big for most individuals or organizations. The government, in some form, has always supported exploration, even going back to Lewis and Clark. That would not have happened, you know, without the support of the U.S. government and Thomas Jefferson. So nothing has really changed since then. Several things have changed in the landscape, in the context for space resource utilization. One is that for all intents and purposes, and by that I mean money, the space station, the ISS, is really finished. And so that the money that's been devoted for space exploration is going elsewhere. And it's widely understood that it is going to extending human presence beyond Earth orbit. Now, whether that's the moon, which seems to be the case now, or whether it's Mars, or in the Obama administration it was asteroids, that commitment is being made. And once we go beyond, you know, easy access, beyond a few hours to re-enter and land and you know, reconfigure you know, a manifest for a space launch, using resources locally becomes very, very compelling. So that's one thing that's changed. You know, the intent to go elsewhere, access for space has, of course, mushroomed, both private and public. And there's been, you know, perhaps a broader understanding that this is a global venture. It's not just one country, one government, and that there are logistics that will contribute to the exploration of space that go beyond just mounting one mission at a time. One thing about in-situ resource utilization, unlike other fields of space exploration, it doesn't demand you be, you know, a geologist or an astrobiologist or a planetary science expert, because it's taking technologies we've developed for the Earth. You know, we do in-situ resource utilization every single day of our lives. That's what one does on Earth. We're trying to transport that technology, to export it to space, to other planetary bodies. So you could be in, you know, the energy business. That's an important one. You could be in, you know, biomedical. You could be in many, many terrestrial fields. And if you will, minor in space utilization. And I have seen more and more of that. I've seen, as you go to meetings, people coming out of all sorts of disciplines, from, you know, from law and from international law and business to ecology, involved in the ISRU area. So I think simply the desire to do it and being mindful of it as one chooses an area to study, a vocation, a place to work, you can get into this field.